And what we're going to see on the next few slides here is a concept called summation. So here's an important point that we have yet to bring up, that we will in the last part of this PowerPoint, is that one single, so just one EPSP, and that's a graded potential, but it's an excitatory graded potential. We call it an excitatory postsynaptic potential. A single one has no chance of producing an action potential, right? So even though it's excitatory, yeah, it's not going to get to the axon hillock because this is graded potential, meaning it's going to lose, even though it's excitatory, it's going to lose steam as it travels towards the axon hillock. So yeah, one single little excitatory postsynaptic potential from one little stimulus is not going to cause an action potential. What you have to do is take a bunch of these excitatory postsynaptic potentials, add them together, and adding is summing, right? So that's called summation. And that summation has to reach threshold at that axon hillock. So yeah, there's a lot of words here, but let's go to the next slide and then to the pictures, and we'll be able to kind of put this all together. Yeah, and summation happens two ways, temporally and spatially. So you have temporal summation and spatial summation. One has to do with time at the same spot. Others have to do with different locations, different spaces, spatial. So again, the picture is going to explain these much better than these words will. So we'll go there now. So in our first example here, this has to do with a no summation. So there's nothing added together here. So what's happening here is they're saying E, so that means it's excitatory. So this is the axon terminal of a presynaptic neuron that you don't see. So this is the very end of the axon terminal in green. It releases the neurotransmitter onto the postsynaptic neuron, on the dendrite of the postsynaptic neuron. So there's the synapse right there. It's an EPSP, it's excitatory. So what does that do? Well, depolarization, but did we reach threshold? Well, no, there's still space there, and that's what we're saying. Just one of these excitatory postsynaptic potentials is not enough to produce an action potential. You get the depolarization, but as it travels towards the axon hillock, it just reduces in strength back to -70, back to rest. So this one little EPSP has no chance of reaching threshold at the axon hillock. Why? Because it's a graded potential and it dies with distance. Send another one in, another excitatory postsynaptic potential in, and the same thing's going to happen. You know, you're going to get close to threshold, but it's going to just dissipate as it travels. So by the time this graded potential, although it's excitatory, by the time it reaches the axon hillock right here, yeah, it's weak, it's died out. So that's the point we're making. With just a single graded potential here, excitatory postsynaptic potential, it has no chance to reach threshold at the axon hillock, because by the time it gets there, it will have died off back to rest. So in this first example, there is no summation occurring. So let's compare it to the next one. So now we have summation, but we have a specific type called temporal summation. So we're looking at basically that same synapse that we saw in the previous slide. Here's the axon terminal of the presynaptic neuron. Here's the dendrite of the postsynaptic neuron. So the synapse is right here. So what happens is, well, we have an excitatory, it's green, it says E here, so we know it's an excitatory postsynaptic potential. So there it is. It's excitatory, it's depolarized, and then it starts resting, but before it can completely rest, we send a second. We see that second arrow? A second arrow, a second action potential is sent in succession. So before it can completely relax, well, now we have another one building on the first one, sort of piggybacking on the first depolarization, and that was enough now to cross that threshold of -55. And once you cross threshold, well, you're getting the action potential: depolarization, repolarization, hyperpolarization, and back to rest. So this is saying that, yeah, this same synapse, the same pre to post synaptic potential here, these two excitatory potentials added together, summed together, was enough to reach threshold at the axon hillock. So it's saying, yeah, these two waves put together was allowed to produce the action potential because we're at -55 at the axon hillock. So you got the first graded potential that's excitatory. It's starting to dissipate, but only went just a fraction of the way down before the second one built on it. So the two action potentials at the same location, that's what temporal summation is, at the same location in succession, right, in kind of a quick frequency back to back, summated to produce an action potential. So here's another type of summation. This is called spatial summation. So what you have is an excitatory synapse, just like we did before, but then we have another excitatory synapse. There's E2, excitatory synapse 2, at a different location, at a different spot. I think of it as a different space, so that's why we call it spatial summation. So let's send one in, stimulate this postsynaptic neuron, at the same time send another excitatory synapse in, right, which will meet each other, and just like two waves in an ocean come together, it'll be double the size. So there's your excitatory synapse 1 and 2 added together was enough to reach threshold. Remember, if we reach threshold, that action potential is going to occur. So there's two EPSPs, two excitatory postsynaptic potentials coming together, meeting each other, creating a larger graded potential that's strong enough at the axon hillock to reach threshold to produce the action potential. So that's spatial summation. And just like temporal summation, you need to add two or more. And realistically, there's actually hundreds happening at the same time. But in simplifying it here, two or more coming together will summate spatially or temporally on the previous slide to reach threshold, to produce the action potential. But remember, not all stimuli are excitatory. In this example here, we do have summation, spatial summation, because we have two impulses at different sites, spatial summation, but one is excitatory, the other is inhibitory, meaning one is going to produce depolarization closer to threshold, the other one is going to produce hyperpolarization further from threshold. And you kind of put the two together and they cancel each other out. So therefore, yeah, this inhibitory will cancel out the excitatory, meaning no chance of reaching threshold at the axon hillock. So this is spatial summation, but realize, yeah, stimuli don't have to be excitatory, they can be inhibitory. And you want to relate depolarization with excitatory postsynaptic potentials and hyperpolarization, right, further from threshold, hyperpolarization with inhibitory postsynaptic potentials.